Hi class, in this video we're going to talk about how to create a frequency distribution and then the following graphs that actually follows the frequency distribution. And the first aspect of this graph is that this is actually used for datasets that are actually large. So if you have a large dataset, typically you'll be creating a frequency distribution because it's easy to identify what type of distribution you actually have. And because this is aimed for a large data set, we typically only use it on a real life scenario from 5 to 20 actual classes. The classes represent how many of the intervals you actually have. So this is the basic formula. It has a title, it has the actual intervals of the classes, and then how many totals of these numbers fit within any of the categories. Now for our class, we're only going to use 3 to 4 for any problem from the homework or any problem that we're going to do later on. If it's not stated, you're going to actually just use 3 to 4. Now for this example, I'll use 5 just so that you see how the actual book is doing some of those problems that have a large data set. So in this case, I'm just going to say we'll use 5 classes. Okay, then once it's decided the number of classes, and like I said, this will be given or you pick. If it doesn't state, pick anywhere between 3 to 4. It's a matter of how you're deciding. You're going to calculate the class width. And the class width is given as the range divided by the number of classes. Range is the maximum minus the minimum over the number of classes. And for a large data set, what I recommend is to enter the actual data set into your list. In this case, I already enter the data set, and in my calculator I have it under L3. So I need you to take a second and then enter the data set. You can pause the video and then run me a one variable stats. So run a one variable stats on L3, and then we'll compare values. We need the actual output of this one to easily identify the value of the range. So for us, the actual class width it's going to be equal to the maximum value, which for us happens to be 486. So 486 minus the minimum value. Our minimum was 30 divided by, and in this case, we're going to be dividing by, well, the number of classes, which is 5. I need you to take a second and evaluate that. And please confirm that I'm getting 91.2, and you're always going to round up. So I'm just going to end up with the values of 92. The always round up is so that you have each of these intervals that are stated here about the same actual length. And let me do the actual setup of this one on the actual on the side. So in this case, this one represents gas money. And then the next part of the problem could be done slightly different in terms of where you start. But our class width is going to be approximately of 92. And then I'm going to start with the minimum value. The minimum value, and let me just reconfirm to make sure there's no errors, started at 30. So this value, it's 30. Now, it's just easier for us in the calculations to get the next value by technically adding 92. So please run the calculation. So 30 plus 92. So I'm getting that the next value, it's going to be 122. And then we'll close the first class. So in this case, this goes from 30 to 121. And then you're going to continue adding another 92. So plus 92, I'm getting 214. plus another 92, I'm getting 306, plus another 92, I'm getting 398. And you're actually looking at 5 classes, so that would be 5 intervals, 1, 2, 3, 4, 5. And then the next step would be to close each of the classes. So this will be 213. This will be 305. This will be 397. And we're going to end up with the maximum value, which we said that was 486. So 486. Now take a second and double check that all of these are actually the result of adding 92, which happens to be the rounded class width. I'm going to pause the video as I double check my actual calculations, and then we'll come back to this in a minute. Okay, the next step is actually to see how many of these total values you see within each of the classes. And the way that we design this is so that when you count 91, that only fits under one of these classes, and you wouldn't have a scenario where you have multiple ones. Now, the next column is going to call the frequency. So let me just label it. And now we're doing the count. Now, it's a lot easier since we already have inserted the list. In this case, I have it under L1 to actually sort it. So what I'm going to do is I'm just going to sort my list. So in this case, whoops, it's going to be L3. And then when we look at L3, we're actually counting now how many values we see between 30 to 121. So you're literally looking at 1, 2, 3, 4, 5. We only go to 121. So for the first class, I see a total of actual 5. Let me double check. So you stop at 121. We don't have a 121 here, so 127 goes beyond that. And then that would be 1, 2, 3, 4, 5. Now, we're going to count now how many we have between 122 to 213. So not to exceed 213. So let me go to the bottom and count up. Okay, so that one's not going to be included. That's 248. That fits under the second category. So we're getting at 1, 2, 3, 4, 5, 6, 7, and I'm counting 8. Now, I'm going to pause the video, and I need you to do the count for all of them, and then we'll see if we compare it to make sure that we're matching. So this is what I'm getting after the total count. So I counted, and it was a little bit hard to count because of the calculator the numbers being so small, but I'm counting that between 30 to 121, I have a total of 5 values. Between 122 to 213, 8 values. Between 214 and 305, exactly 5. 306 and 397, 5. And 398, 486, a total of 3, with a total value. And in this case, the total value, you don't have to do the count by hand. That's given by the one variable stats. So I counted, well, actually it was given as a total of 26. So you technically have a total of 26. Now your final answer may be slightly different if you were to look at how these are constructed on the book, because we're basically adding the 92 and that value's here. You could have added the 92 and then the 122 would be in this position. The idea is that this class width, it's approximately 92 in any way that you're actually organizing it. It's also possible that because of the discrepancy, you're putting the 92 here or there, you end up with a slightly different graph. That would mean that some of these may get shifted as they go to the next class if these classes were to be different. But this is it for the frequency distribution. You're basically just giving us the count. Now for any future exam, if it's timed, I wouldn't give you this large data set because it's kind of hard to count. It'll be smaller, and if it's not stated how many classes, you pick 3 to 4. Now, let's take a look at the next graph, which is actually obtained from the frequency distribution, and this is the relative frequency distribution. Now, the relative frequency distribution actually contains the frequency distribution, which is technically this part, and then you're using all the values that you started there, and then you're adding the relative frequencies. Your relative frequencies could be expressed as an actual decimal or percentage. You're only putting percentages if you're told. If not, you're not actually required. So these will be percentages for each of the classes. Now we counted a total of 26 total values for the data set, and that's basically given here as 26. To create the relative frequency distribution, all you have to do is basically create the following division among each of the values. So this will be 5 divided by 26, 8 divided by 26, 5 by 26, another 5 by 26, and then 3 divided by 26. Each of these would be given as first decimals. And then if they're not asking anything else, that would be the answer. So the first one, I'm getting 5 divided by 26. That is approximately, I'm going to leave it as 1923. So this is approximately 19.23%. Then 8 divided by 26, I'm getting 0.3077. And I'm just rounding to 4 decimal places. So this is 30.77. And we're actually rounding. The next two are actually the same as the first one. So 0.1923 or 1923%, 0.1923, so 19.23%. 3 divided by 26. This is 0.1154, so 11.54%. That's the only addition that we're actually doing to the frequency distribution, and we're just basically adding an extra column. It's only sufficient to include the actual decimals. You don't have to provide the actual percentages unless they're actually stated. Now I'm going to pause the video here because it's actually running out of time for me to record. We'll do the other two on the next video.